Hello, my name is Sophie Hollitt, and I'm here to present on behalf of the LHCb collaboration and tell you more about mixing and CP violation in CHARM at LHCb. So to begin with, a brief overview of CP violation and mixing. The universe, as we know it, has much more matter than antimatter, but the CP violation in the standard model is not enough to explain this asymmetry. What this means is that precision measurements of CP violation and mixing could be useful to us in order to discover extra asymmetry and thus new physics. Now, if we zoom in on the CKM triangle here and take a quick look at some of the angles, if we look at alpha, this can be measured using B goes to pi decays with some extra isospin rules. This angle gamma can be measured using B or BS goes to D pi or D multiple hadron type decays. And this can interestingly be measured at tree level, which means we don't have to worry so much about contamination from extra types of decays. And if we take a look at the CKM matrix here, this mixing phase beta S measured in the interference between direct CP violation and mixing, such as in decays like BS goes to J psi, K plus, K minus. And in particular, we notice, so we have this decay B goes to final state, or B mixes to B bar, and then this same final state, and we have the interference between these. So that was B quarks, so you might be wondering, what about CHARM? So we had an observation of CP violation in CHARM in 2019, and this was a direct CP violation measurement. Very exciting, but the reason we care about this as well is when we're looking at that big picture about the universe, in terms of the beyond standard model effects, the CP violation in CHARM may actually be completely independent from the down quark sector and our beauty quarks. So what this means is this is a new and rich area of investigation for experiment and for theory. So let's take a look at what I want to talk to you about today. We have a lot of topics to get through. So first of all, in terms of beauty, we have more about the BS system and measurements of gamma. We have the K-pi puzzle, which is related to measurements of alpha and those isospin rules. And we also have a search for CP violation in baryons. And then in terms of CHARM, I have quite a few things to tell you about. We've got some time-dependent CP violation measurements. We've got some searches for CP violation in decays with neutral light mesons. And we've also got something exciting today about some of the mass mixing parameters for the neutral trial. Now, of course, I'm here to just present on LHCb today, but if you are interested in what's going on at the other LHC experiments, there are some CP violation results from Atlas available as a poster during this workshop. So let's begin with mixing and CP violation in beauty. So first of all, before we talk about anything else, we need to explain how we measure mixing. So flavor tagging is needed to help us identify the initial state of the B hadron, especially if both the B and B bar are decaying into the same final state. So what we have here in blue is our decay with our original B quark in it. And we can either take a look at the decay products on the opposite side, So this is where the other B quark in the pair has formed a hadron and decayed. And we can also look at the same side information where, say, this extra light quark that's paired with the B is related to another pair whose decay products we can monitor. So that's what we have for beauty. And in CHARM, what we often do is we can identify the flavor by choosing our D0 or D0 bar candidates that come from D star decays. So what this means is we've got the D star plus, and say this has a CHARM quark in it. We go straight to the CHARM quark in D0, which might mix, but we can still identify that this is originally a D0 because of this pi plus that we also reconstruct. So now that we've discussed flavor tagging, I'd love to move on to a summary of the delta MS results at LHCb. So we've had two results recently, both of them with the most precise measurement at the time. The slightly older measurement is this BS goes to DS 3 pi decay. And the newer one is from DS pi. And if we take a look here, we've got some excellent precision in our LHCb average now. So this delta MS is the difference in mass between the two eigenstates, the two mass eigenstates of the BS. If we want to plot the probability of the final state In the beta case, this is related to whether or not we've had mixing. And we get this nice simplified shape, and we can see this lovely ripple shape in both of our experiments. And the final result, most precise .ms to date from DSPi is just here. But not only DSPi, we also measured gamma in the same study as this ds to 3 pi. We also measured bs goes to dsk 2 pi. And there were two different fits here to the CP parameters to give two independent results. But when we take a look, we've got this nice mass of the dsk pi decay here. And when we're taking the separation of the two different final states in this decay separated by the charge of the kaon, we see this lovely separation and asymmetry. And our result is for gamma minus 2 beta s, so we have the mixing in there as well. And when we have beta s from another measurement, we can get a value for gamma. So speaking of gamma, we've also had some measurements of gamma from B goes to DH decays or D star H. And in this particular paper, there were actually lots and lots of measurements, a very high number of measurements of CP parameters here. But what I want to talk about is this one where we have D0 or D0 bar goes to K plus K minus, and the B is D0K. So I included this plot just because the asymmetry is very obvious and nice to look at here. But when we put together the results from this paper with some other LHCb results, we get these lovely averages for LHCb, and we have this updated LHCb combinations for gamma. So just from the contributions of all the B plus modes, we have gamma is 64 plus 4 or minus 5 degrees. Whereas if we put together gamma from all of the B modes that have been measured at LHCb, including BS, we get 67 plus or minus 4 degrees. So moving on from there, I mentioned briefly how to measure gamma. We need to have a good understanding of this mixing parameter beta s, and this is a new measurement that helps to give us more understanding on that. So here, this is a measurement of BS goes to J psi E plus E minus phi. So this has different systematic uncertainties compared to the same decay with J psi goes to muons. So this gives us an independent check of our systematic uncertainties. And for a further check, the mass fit here is divided into 3 categories based on whether the electrons are Bremsstrahlung corrected or not. So to get a result here, it's an unbin fit. We have the BS decay time and 3 different helicity angles. And so in this plot here, we have the decay time here and the 3 helicity angles in the fit divided up into which states they come from. So we have 2 different CP even components and 1 CP odd component. And when we put all of this together, we get one result for delta gamma S, which is the decay time difference between the 2 BS states, and we also get our phi S mixing angle. And excellently, this is compatible with the J psi goes to mu mu result and the standard model. So moving on to the K pi puzzle and light hadrons. So any kind of B goes to H1, H2 decay can be useful for CPV parameters. So first of all, we contribute to measurements of the alpha angle. But if we combine U-spin measurements of B0 goes to pi plus pi minus and BS goes to K plus K minus, this also lets us measure gamma. So in terms of this spin argument, we have the K pi puzzle. So isospin arguments imply that the CP asymmetry between B0 goes to K plus K, the CP asymmetry between B0 goes to K plus pi minus and the CP asymmetry between B plus goes to K plus pi 0 should be 0, but the current average of the difference is actually non-zero at about 5.5 sigma. And if we take a look at a more complicated version of the isospin rules, we can see that the branching ratios come into this too. So what we actually have is some updated results here. So first of all, if we take a time integrated study of the CP violation in K pi, we see this lovely effect. This particular plot is from the opposite side tagger, and that gives us this result here circled in blue. This is the CP violation in D0. So that will be useful for looking at the K-pi puzzle in a minute, but this paper also includes a time-dependent study of the K plus K minus and pi plus pi minus modes. So if we take a quick look here, I've shown the plot for K plus K minus because this is the BS mode, and we have those same lovely delta MS type ripples that we saw in some of the earlier papers. So that was looking at the B goes to 2 charged hadrons. And now if we take a look at the B plus goes to K plus pi 0, this is actually a somewhat difficult measurement to make at LHCb because neutrals are quite difficult to reconstruct. We have the K plus, which gives us a single charge track, and then the pi 0 is reconstructed from the calorimeter information when the pi 0 decays into 2 photons, and we can bring that back to try to reconstruct our K plus pi minus. Now, in terms of the theory side, this decay should be very similar to the previous one, the K pi, but it has some extra contributions from color suppressed diagrams. So when we take a look and when we remove all the production asymmetries and things, we take a look at this result, we get a nice result for the asymmetry. If you've been paying attention on the previous slide, you'll see that when we take the difference between this new result and the previous one, we get a very large non-zero difference in the asymmetry again. So now the world average of the CP asymmetry in the K-pi puzzle is now at 8 sigma instead of 5.5. So there's definitely a lot of interesting physics going on in this area, and we have a lot more to learn. Last but not least, for CP violation in beauty, we have this search for CP violation in the Chi-B goes to proton KK decays. So symmetry breaking has not been observed in the baryon sector at all yet. A large CP violation is present in B goes to 3 hadron decays though. So in this study, we're taking a look to see if a B hadron goes to, if a B baryon decays to 3 hadrons, whether we'll also see an enhancement. And this is an exciting study that also has a Dalitz analysis to try to look for resonances in this decay. So we have 6 different resonances here that were identified, but in all of them at the moment, the CP violation is consistent with 0. So moving on from our results in beauty, I'd like to talk next about mixing and CP violation in charm at LHCb. So to begin with, we'll start with an update of that 2019 study. So rather than a time independent, this is now a time dependent study. So given that the mixing in D0 decays is expected to be small, we can consider a linear expansion in the CP asymmetry to get this parameter delta y, which is related to the decay time difference. And in other notations, you might be more used to this a gamma f term. So this is performed using some extra cross checks to D0 goes to K pi decays, and it uses the D star flavor tagging that we talked about earlier as well. So here we fit the mass of the D star, and we have an extra region to control for background effects. And when we take the asymmetry and fit this line to it, we get these updated results for delta y in each of the modes, and then a combined measurement for them together. And this is a factor to update in the precision of these measurements. Next of all, I'd like to take you through a discussion of searches for CP violation in D or DS goes to H plus pi 0 and H plus eta decays. So here again, we're looking for cross-checks of isospin sum rules. The difference here compared to the K-pi puzzle is we're expecting that the CP violation, the CP asymmetry in D goes to pi plus pi 0, we expect that to be 0. So when we take a look, we reconstruct the pi 0 and eta in this case, rather than just as 2 photons in the calorimeter, we look for situations where one of the photons has been converted to E plus E minus, or we just look for the E plus E minus gamma decay mode, which gives us a nice charge tracks to look for that we can use to reconstruct the point where these decayed. So when we put this together and make a simultaneous fit to account for any misidentification of the pion and kaon, we get all these lovely results. And if we take a look at the pi plus, pi zero in particular, this is still consistent with zero and consistent with the standard model at the moment. Another thing I'd like to talk to you about, again, charm with using neutral hadrons. So here we have D0 goes to K short, and this channel is sensitive to different amplitudes than the H plus H minus decay modes we looked at first. So in order to reconstruct this mode, each K short is reconstructed from charged pion pairs, so pi plus, pi minus, and these are either reconstructed in the detector as long tracks, where we go through all of the tracking stations, including the velo, where we have a very high quality reconstruction, very good mass resolution, or sometimes they're reconstructed as downstream tracks, where when the K short has decayed too late to be reconstructed in the velo, we just have a downstream track in the other station. So if we take a look, the fit here is performed in different data categories for each of these different K short reconstructions. So here we have one for the LL from 2 long tracks. So this gives us a nice shape, and we have this one from the downstream tracks. It's a bit broader. And depending on whether the D star is from the primary vertex or not, this is also another data category. So here we take a simultaneous fit to the mass difference between the D star and the D0 and the mass of each K short, and this gives us this lovely result for the CP asymmetry. This is an updated result for 412. And at the moment, this is still consistent with no CP violation at 2.4 sigma. So one of the new results from LHCb that I'm excited to tell you about, absolutely hot off the presses this week, is the looking for the mass difference between neutral charm meson eigenstates. So this mixing parameter here, we have X, which is related to the mass difference, and also Y, which is related to the decay time difference. And in this decay mode, we have about over 30 million D0s. And for this particular analysis, this is performed in Dalit bins of similar strong phase. So this is trying to correct for any possible effects from the strong phase. We create bins that have the same strong phase and do a different fit in each of these. Similarly, the simultaneous fit is over 4 different independent samples. We have 2 types of K shorts, once again, and we have 2 different types of vertex requirements on the pions. And when we put this all together, this is very preliminary, but we've got what looks like some very exciting results for this mixing parameter. It looks like we're not consistent with 0 anymore. So this would be an important observation of the mixing between the 2 D mass eigenstates. So moving on to our summary, there have been a lot of exciting results in the past 6 months. I hope I've given you a good overview of them. Our newest results today, which are less than about 2 months old, we had 3 from beauty and 3 from charm. In particular, we have the most precise measurement of delta MS. We have this search for CP violation in the baryon sector, and we have the first measurement of CP violating phase in this BS goes to J-sci-fi mode using electrons. We also have the most precise CP asymmetry result to date from D0 goes to K short. We've improved the precision in delta Y measurements in D0 goes to H plus H minus, and we've performed a time-dependent study there. And we've possibly observed this mass difference in the neutral D system. And if you want to hear more about that, you have to take a look at the CERN seminar coming up next week. So at the moment, the Large Hadron Collider is working on an upgrade. More data at increased luminosity is coming in the next few years. And at the same time, we'll be continuing to look at this data that we already have for more exciting mixing and CP violation results. Thanks so much for joining me today, and have a great day.